All right, so let's take a look at the same graph and the same equation a little more in depth. So the equation of this graph we already know is x squared plus 2x minus 8. And we know that its factored form, okay, is not going to work right now. What's going on? All right, x plus 4 times x minus 2. But how did we get that? Okay, well, from this equation, so look the bottom left of the screen, from the equation x squared plus 2x minus 8, okay, I asked myself, what multiplies to negative 8 but adds to 2? So I took the number 8. I realized that it can break up into 4 and 2. All right, and I realized that if this is a positive 4 and this is a negative 2, that I add to 2. So I said, well, this must be x plus 4 times x minus 2. That's what I did there. Okay, so we know that we have x-intercepts where intercepts the x-axis. So we see that we have those at negative 4, 0 and 2, 0. We can find those on the graph. By the way, look down at the bottom of the screen again. If I set this equal to 0 and solve, look what I get. X equals negative 4, x equals 2. Not coincidence, those are the same answers as your x-intercepts. Now, your y-intercept is found when x is 0. So we would do 0 squared plus 2 times 0 minus 8, and you'd see that we get our y-intercept is negative 8. Okay, all I did there was I put 0 in for x. Okay, your leading coefficient is your a value. So that is the value in front of x squared. In this situation, there's nothing there. So it is assumed it is a 1. So your leading coefficient is a 1. Our axis of symmetry is where it is split in half. Okay, you can find it at its min or max, and it's the x value. So here we have a minimum of negative 1, 9. So our axis of symmetry is x equals negative 1. Parabola opens which way? Okay, this one, it looks like a U, so it opens up. If it was upside down, it would open down. All right, find a point symmetric to the y-intercept. So we know the y-intercept is at 0, negative 8. Okay, and we know that the vertex is at negative 1, so we'd move one more to the other side, okay, which would be negative 2, 8. What do we notice about it? It has the same y value. That would not change, okay, but it would have to move another unit over. We already said our vertex is at negative 1, 9. That's our bottom point. Does the vertex represent a min or a max? So what's our lowest point? So it is a min, okay? Increasing and decreasing intervals. Well, it is going downhill, okay? So this way, from negative, so it's decreasing, we'll say d equals negative infinity. It's coming from negative infinity all the way down to x equals negative 1. And it's increasing from negative 1 to infinity, okay? That's the lowest point, and then it starts to go back up. And then for the last part, it says find the average rate of change on an interval. So from negative 1 to 0. Well, let's think about this. From negative 1 is negative 9 to 0 is negative 8. Okay, over negative 1 minus 0 would give us, let's think about this, negative 9, that would be negative 1 over negative 1. Okay, did I do that right? So from negative 1 to 0, okay, would be an average rate of change of 1. Okay, what is the average rate of change from 0 to 1? That should be negative there. All right, let me fix this one. We're going to go back. We're going to fix this. Hopefully we're not running out of time on this video. All right, the average rate of change from negative 1 to 0. I did not like my explanation. Negative 1 to 0 goes, what am I doing? It's going to go from negative 9 minus negative 8 over 0 minus negative 1 is going to give me negative 1 over 1. So the average rate of change was negative 1. Okay, I knew I did something wrong. All right, from 1 to 2, we're going to skip the middle one because we're not going to have enough room. From 1 to 2, let's think about this. The value at 1 would be what?